Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So x to the power of x is equal to x to the power of 2. And now I'm going to divide both sides by x to the power of 2. So if I divide both sides by x to the power of 2, I get x to the power of x over x to the power of 2 is equal to x to the power of 2 over x to the power of 2. And x over x to the power of 2 over x to the power of 2, these two cancel out, and I get 1. So I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So x to the power of x over x to the power of 2, that's the same thing as x to the power of x minus 2, which is equal to 1. Now, I'm going to take the natural log or ln on both sides. So I get ln x to the power of x minus 2 is equal to ln 1. So if I have something in the form ln a to the power of b, I can move this exponent and b to the front. So it's going to equal b times ln a. So in this case, I have ln x to the power of x minus 2, and I can move this to the front. So I get x minus 2 times ln x is equal to ln 1. Now I can distribute the ln x. So I get x times ln x minus 2 times ln x is equal to ln 1. And ln 1, that's equal to 0. ln 1 equals 0. So now I get x times ln x minus 2 times ln x is equal to 0. Now I'm going to go back and factor out ln x. So I get ln x times x minus 2 is equal to 0. And now I get two equations. I get ln x is equal to 0, and I also get x minus 2 is equal to 0. So for ln x equals 0, we already know that ln of 1 is 0, right? So x equals 1. That's one solution of x. And for x minus 2 equals 0, that's simple. All we have to do is add 2 on both sides. And I get x is equal to 2. So x equals 1 and x equals 2 is my solutions. Now, going back to the original equation, we have x to the power of x equals x to the power of 2. So to check, I'm going to first start by plugging in x equals 1. So if I plug in x equals 1, I get 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1. So this is right. Now if I plug in x for 2, I get 2 to the power of 2 is equal to 2 to the power of 2. And 2 to the power of 2 is 4, 2 to the power of 2 is 4, so this is right as well, meaning my two solutions are right. Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So I'm going to first start by letting y equal 2 to the power of x. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 3x, that's going to equal 2 to the power of x to the power of 3. Now I have this plus 2 to the power of x is equal to 10. Now I'm going to let 2 to the power of x equal to the variable y. So I get y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. And now y, I can rewrite this as 5y minus 4y. Now from here, I can factor by grouping. And before I do that, I'm going to switch the order of 5y and 4y. So now I have y to the power of 3 minus 4y plus 5y minus 10 is equal to 0. So now if I factor by grouping, I can start with y to the power of 3 minus 4y. I'm going to factor out y, so I get y times y squared minus 4, plus from 5y minus 10, I have 5 times y minus 2 is equal to 0. Now, y squared minus 4, I can rewrite that as y plus 2 times y minus 2. And now from here, notice that the only common factor for all these terms is y minus 2. So I have y minus 2 times y plus 2 plus 5 is equal to 0. And now if I simplify this, I get y minus 2 times y squared plus 2y plus 5 is equal to 0. And now I get two equations. I get y minus 2 is equal to 0, and y squared plus 2y plus 5 is equal to 0. So for y minus 2 equals 0, y is obviously equal to 2. And for y squared plus 2y plus 5 equals 0, we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I get y is equal to negative 2 plus or minus the square root of b squared, so 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a. So 2 times 1. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16, over 2. And I can write this as negative 2 plus or minus the square root of 16 times the square root of negative 1 over 2. And this is equal to negative 2 plus or minus the square root of 16 times I, because the square root of negative 1 is equal to I. And the square root of 16, that's equal to 4. So I get y is equal to negative 2 plus or minus 4i over 2. Now if I divide 2 with both these terms, I get y equals negative 1 plus or minus 2i. Now, remember how we let 2 to the power of x equal to y. So I get 2 to the power of x is equal to 2i minus 1. And I get 2 to the power of x is equal to negative 2i minus 1. Now, we can't actually take the power of a positive number and make it equal to something with I. So there's no solution for this, meaning that we can only use y equals 2. So I get 2 to the power of x equals 2, meaning our only solution for x is 1.